All right, y'all, it's 8:35. We're going to get started because we have a lot of information to cover today. So if you haven't already, please join our ed discussion. We will make announcements all on ed, office hour cancellations. If you need help, create a post in ed discussion. So yeah, please join that if you haven't already. And by the way, this link will be in the course website. So if you didn't get the QR code scan, then you can go into the course website. All right. So just some quick announcements. If you haven't filled out the course roster, please do that as soon as possible. I will release A1 tonight, and I need that in order to add y'all to CMS as well as to GitHub. So please do that as soon as possible. Make sure y'all also have Xcode and Git/GitHub installed. And then, so yeah, in the course website, if y'all go over to the office hours tab, let me zoom in a little. So these office hours, we haven't found like a room for it yet. And so the location, I believe they mentioned that it's going to be on Zoom. But for these office hours, we do have a location for it though. But once we get a location, we'll put it up here. So I heard that there were some issues about enrollment, but I believe they fixed it now. Who here still has issues with enrolling on Student Center? Okay, none of y'all? Okay, that's good. All right, are there any questions about course logistics? No? Okay. So yeah, just to recap, in last lecture, lecture 0.5, we basically discussed the basics of Git and how we're going to be using Git inside of our course. And so what Git is, it's a distributed version control system that allows you to track the changes in your code base. And what distributed means is that it allows you to work offline and collaborate with other people and then push it into this remote repository where you can kind of share your code base with others. And so just to clarify the difference between Git and GitHub, Git is a software, and then GitHub is a service that provides the software. And then remember the three things. If you are working with a partner, make sure y'all pull. If you're like working separately, then make sure y'all pull before you make any changes to your code. Once you've pulled, then just remember the big three. You start by staging your changes. In other words, you're telling Git which files you want to push to the remote repository. And then you will create a commit, which is basically a snapshot of all the changes in your file. And then you want to push it to the remote repository. That way other people can see it. Are there any questions? All right, so we're going to get started with actual Swift and iOS development. Richie will lead us off with variables and constants.
Sounds good. So yeah, we're going to jump right into Swift today, and hopefully if most of you guys have Xcode downloaded already, because I will be demoing today on Xcode. And if you do have Xcode open, I will sort of create a file and show you guys how to do that so you guys can follow along as well. So, all right, so if you guys open Xcode like this, once you open the app, it may take a bit to load the first time you open it, but once you do open it and it does load, it'll sort of give you this interface. You most likely won't have anything up there because you probably haven't created any apps yet. But today we're not going to create an app. We're just going to utilize a playground, which is essentially just a place where you can just test Swift code and run code as well. So it's not an app. We're just going to, so to do that, we're going to go to, File, and go to Xcode, and then you'll see up here there's a File button, and then click New. And to the right, you'll see Playground. So you'll create a new playground, and we want it to be blank. So you just click that, and then L1 demo. We want to create this desktop.
Yeah.
All right. So it should be, there we go. So once you create that sort of playground file, you'll sort of have this basic setup right here. And if you want to like run any line of code, you'll see that there's this little play button to the side right. And if you click it, it also may take a while too, because it might be your first time running Xcode. You will notice that your first time running Xcode when you boot up your computer, it will take a while. This is one of the things that you have to deal with when you're coding iOS. It just takes a while. but eventually it will run. It's just on startup, it usually takes a while to run any sort of program. So I guess to jump right in. So I guess there's already an example of this on the screen right now with the basic stress sort of setup they have. But in Swift, there's sort of two ways you can store data. You can store data in the form of a constant, and you can also store in the form of a variable. So the main difference between those two is mutability, meaning a constant is immutable, meaning you cannot change it once it's set, whereas a variable is mutable, meaning you can change it as you go and continue to edit the same variable, whereas a let constant stays the same value throughout. So we're going to demonstrate that. Okay, yep. So to demonstrate, let's first try to define a constant. Perfect. All right. So to define a constant, you need to use a keyword let. And that sort of tells Xcode or Swift that you are trying to define a variable. And it will sort of give you errors as you go if you don't sort of type quickly, or if you have any errors in your code, Xcode will let you know. So that's a nice feature of Xcode, is that you will be notified if you have any errors in compilation. So to define a constant, so let's call it constant. We use a let statement. Let's call it const. And then we want to set it to a value. So let's say we want to do ven here. So that is a constant. Now the thing about a constant is, like I said before, the value in the constant will never change once you set it. So the first time you set a constant, the value will maintain the same throughout. So let's say you wanted to try to change the constant to something else. We'll sort of get an error from Swift or Xcode that you cannot assign a value to a constant. So let indicates a constant, meaning you cannot change that value once you do set it. So actually, a helpful feature of Xcode is that if you sort of see the circle icon here, you can actually click here, and it'll give you sort of the fix for that. So if you click fix, it'll actually change that constant to a variable. So you see the let change to a var. So that's the other form of data storage, is using a variable. So in this case, using a variable, now all of a sudden your variable is mutable. So the value can change as you go, meaning the first time you set a variable, it doesn't necessarily have to stay that value. You can continue to change that. So it may seem confusing why at first we need sort of these two different types. So let me actually just define both of them here, just so you guys can see. Oops, that should be a let. This first one is a, this one, and also to write comments, you do double slash. This one is a constant, and if we want to define a variable, use var, and then variable equals, and then define something else. So top is a constant, bottom is a variable. So it may seem confusing why there's sort of two different types of ways we can store this, that like why not just make everything a variable? But you'll see later on that sometimes we don't really want something to change once you set it, but that'll come later on in sort of the course when we sort of move on to more UI development and that sort of aspect. Right now for like just values and like strings and everything like that, it doesn't really make sense as much to have constants versus variables, but later on when we do sort of have UI elements and that kind of thing, you don't really want certain elements to change or have risk having certain aspects of things change because of that. So that is an important distinction. That sort of is, I guess, the basis of Swift. Okay, so I guess that's this from variables and constants. And I guess a recap. So variables and constants, they both store data. And I guess a good analogy is to think of them as boxes. So I guess a constant or a let statement to define a constant is a box that's sort of closed off the moment you put something into it. So when you just think of it as a box that's closed, and the same thing with a variable, except that it's open and you can constantly take things out and replace things. And yeah, so you can always use a constant until you need to change the value. Whereas with a variable, you can continue to change the value regardless of what you define it as first. Constant will always stay constant. And we use, to define a variable, we use the var keyword, and to define a constant, we use the let keyword. So that's just a quick recap of variables and constants. So I'm going to give it to Vin for data types.
All right, so I'm going to go over data types in Swift. So what Richie just created here, does anyone know the data type of this variable? Someone? Y'all can just yell it out. A string, right. So if you're taking 1110 or if taking any CS course, then this right here is a string. And so are there any other data types in Swift? Well, of course, it's a programming language, so yes. So I'm going to comment these out and just create a variable. I'm going to call it instructor. So earlier, if you create a variable called instructor, and then if I put my name, why does Swift not give me an error? Well, that's because there's this thing called type inferencing, which basically Swift will figure out what kind of type this variable is holding. So you can actually define or provide a explicit type to this variable. So let's say I just created this variable called instructor and I didn't assign it an initial value. All right. And now I put in, let's say instructor is equal to Vin. Now what's going to happen is that Xcode is going to get mad at me. It's basically saying that it doesn't know what this type of this variable is. Even though I assign it equal to a string right here, when this variable is being declared, it needs to have a data type. And so what I can do is provide it an explicit data type by using colon and then the type of that variable. So in this case, it was a string. And now it won't give me an error. And so in addition to a string, there's also other data types. So let's say I make instructor a string. What happens if I make it some kind of number? So if I put in 2, what's going to happen is that Xcode won't allow me to, Swift won't compile because I declared this type, this variable, to have a type string, but then I gave it a value of an int. So now there are also other data types with Swift. There's also a string, or there's also a double. So I could say let's, I guess num will be equal to double is equal to 2.0. So if you're taking 1110 or 2110, then you also know that there's also this thing called a float. I'll call it num floats. So I guess the main difference between a double and a distributed float. The main difference between a double and a float is just basically how much storage it takes. Normally, you can use a float or a double. In this course, we don't really care much about it. And then, of course, there's also other types there's another type called Boolean. So let's, I don't know, like is valid be some kind of bool. So bool stands for Boolean. And this can either be true or false. So is valid is true. I can now assign it another value of false because this type is a Boolean. Yeah, so now just to recap, Swift is statically typed, so there's a thing called type safety. In other words, I have to provide it some kind of type during initialization, either through type inferencing or by explicitly giving it some kind of type. And the other data types, there's an integer, there's a Boolean, string, float, and double. So those are like the common data types that you will be using. Are there any questions? Yes.
Is it still common practice to initialize it with a data type even though it has like type inferencing?
Yeah, I guess it depends on the developer. Me personally, I like to give it a type just to make it more clear. But then again, if you're using it within like a small function, then sometimes you might not even need to give it a data type. But normally, I usually do give it a type. Yes.
What's double?
Yeah, a double is just basically any number with a decimal point. It's the same thing as a float, but it just takes up more storage.
So if you think about the number pi, a double will sort of have more of those digits of pi as you go on, whereas a float cuts off at a certain point. So if you store pi into a double versus a float, you'll have more digits to go by. They're usually more accurate to use a double, but in this class, there's not really a difference between them. We're not really using too many data types here.
Yeah, one thing to mention is the common practice for declaring these types is that you want to use a colon followed by a space. So you don't put a space. You can, but usually we don't. You want to use a colon, space, and then the type. One thing to mention is that notice how we use camel case. So that's just the convention for Swift. You can also use snake case, but a lot of programming languages have like their own convention. You know, like Python, we usually use snake case, but in Swift we use camel case. All right, so Richie is gonna teach y'all operators now.
Okay, so Vin covered some of the basic types, and now each of those types sort of have some of their own unique operations that we can go over. So you may be familiar if you've taken 1110 or any other programming you've done in the past that you can perform operations as if, for any programming language, as if it were a calculator. So let's first define a variable called a, and let's call it 0. And so basic operations, so a is currently an integer since it's 0. You don't, since it's not 0.0, it is not a float or a double, it is an integer. So some common operations that you will see, so if we do addition, you'll sort of see that, it works addition. There's also subtraction as below, equals a times 2. So that's multiplication right here. We also have division. And another one that you may have seen if you've taken 1110 or any other programming course is something called modulo, or remainder. So that essentially is the same. You take division, instead of outputting the actual answer to the division, you output the remainder for what you would get with the division. So as you can see now, everything is with an integer. So all of these operations apply to all of the number types in Swift. So right now, I'm performing all of these operations on integers. But let's say we wanted to perform them on a float. And you wanted to say, like, divide maybe, or like add 1.0 to 1 as using a float and adding it to an integer. All of a sudden, you see that you cannot convert a value of a double to a type int because you sort of, the left side of your operation a is 0. It's not 0.0. So 0 is an integer, and your right side is a double. So sort of, Swift is telling you that, oh, I don't know what to do here. I don't know which one to cast. So Swift is not going to auto-cast in this situation. It's not going to convert from a double to an int or an int to a double. So it's saying, essentially, you cannot sort of mix number types in your operations unless without explicitly casting or changing types. So in this case, you cannot add an integer to a double or a float. But let's say you change 0 to 0.0, then we have the case where that one will succeed, but the ones later on will fail, because we sort of are unable to perform those operations on doubles. So again, if you're trying to modulo with a float, again, it's having difficulties unless we sort of change everything to a floating point number. Again, there's a lot of errors here because, again, you have to keep everything consistent. So these integers are causing issues with the values here. So anytime you sort of have these number operations, you need to make sure that you're either performing operations with a float or an integer with an integer. There are certain situations where Swift will do autocasting, but it's always safer to sort of specify the type of value. So if you're using a float, just add a 0.0 if it's an integer. Otherwise, cast to an integer and everything like that. So those are the sort of the basic operations on numbers. We also sort of have comparison operators. So those are values that sort of compare two values. So if your standard equals, which is equal to, this will return true. So I don't know if that'll show up on the side. Does it show up? Okay, there we go. So you see on the right there, it'll say the output. It says that 2 is equal to 2. So that is your comparison equals operator. And then we have less than or equal to. So see there, it's also less than or equal to. But if we did sort of 3, and then we ran it, that would give us false. So that is less than or equal to. It's the same thing with less than. It's just just the basic how it would work in arithmetic as well. So that we have less than or equal to. We also have greater than or equal to. Same notation like that. It's very similar notation to Python if you're familiar with that, or any like most coding languages. And we also have not equal to. So this would be true as well. So if it's not equal to, it'll return true. Otherwise, it'll be false if they're equal. And yeah, as you can see, they're not equal, so it'll be false. And am I missing something?
We can just show the table later.
Okay, yeah. And then I guess another operation that sort of, another type that Vin went over was the Boolean. There's also operations between Booleans as well. So you can or, and, not. So it's the same thing here. So you can say true and true would be true. So if you're familiar with how sort of that Boolean operation works, If they're both true, then it'll return true. Otherwise, if one of them is false or if both of them are false, the statement will return false. Like that. It takes a while. And we also have the OR statement, which is the double line like that, which also operates the same as an OR statement in Python, where if one of them is true, then it will return true. If both of them are true, it will return true. And the only case it will return false is if both sides of the operation are false. And I guess that's it for Boolean operations. There are a few more, and they will be on the course textbook, and if you want to like have more detail on them, but we're just going to go through this because we have a lot more to cover. And I guess one more thing that's pretty important is string interpolation. So is anyone here familiar with what concatenation is? Yes. Can someone tell me? Yeah.
Adding two chunks or two separate strings together.
Right, yeah, exactly. So let's say we had a string called hello. String hello. Hello world. Yeah. Oops. And let's say you wanted to add something in the middle, not necessarily at the end. So with concatenation, you can't exactly do that, where if you add hello world, the string with something else. So you would actually have to separate the string like this, hello, so plus, so if you sort of have that, then you can add a word in the middle there. Whereas there's an easier way to do this in Swift called string interpolation. So rather than having you concatenate and then separate the string into different chunks and then adding them in order, you can actually take a string, say hello world. Let's say we had a variable called C, and then we'll call that. So if we wanted to sort of add this middle word into this string right here, instead of splitting it up and concatenating them in order, we can actually use string interpolation. So that involves a backslash and two parentheses. And whatever we want to insert in the middle of the string, we can just add it there. It can be a variable or any value there. And if you see and run it, it'll actually directly insert it into the middle there. That runs. So we're going to track this out. Okay, so you can see that it actually inserts it in the middle. So rather than having to separate the word and concatenate them separately, you can actually use string interpolation to insert a variable or an actual string in the middle of the string rather than having to break it up. So this will usually be the convention in this course. We don't really want you to use concatenation. It's kind of slower and it's like less sort of conventional to use concatenation. So it's always better to use string interpolation. Even if you're just adding it to the end, you can use string interpolation at the end still. Let's say you want to add an exclamation point. You could even just add it like that. Or you can store it in a variable and it'll save it as well. So it's always better to use string interpolation rather than concatenation. Okay, so I guess to summarize everything else, so we have the basic operations on numbers, plus, minus, multiplication, division, and modulo. And we also have, they work on different types, ints, doubles, and floats. And we also have type casting, which sort of just treats the variable or value as a different type in the operation. We're not really going to cover too much of that in this course because it's not as required in a lot of things. You'll see later on when we sort of cover different units that will have some mentions to casting, but most of the time you won't need to do casting, and if so, Swift will do it automatically for you in certain cases. And then we also have string interpolation, so rather than using concatenation to add strings together, you can insert chunks of strings into others using interpolation, which is the convention we use in this course. Any questions? Okay. Okay, I guess we have...
Yeah, so those are like the basic operators. We'll post the lecture slides online, or you could just read the textbook. So yeah, so recently, or before, we covered some basic data types. You have ints, strings, booleans, but those are just like very basic data. Like we're only storing text or numbers. But sometimes, or most of the time when we program, we want to store a collection of data. So in 1110, we use this thing called a list or even dictionaries. Similarly, in Swift, we also use a list in a dictionary, but instead of a list, we call it an array. So I'm going to quickly demo what an array is. So an array is just basically a collection of data. So I'm going to create a variable. I'm going to call it staff. So I'm going to create a collection of all of the staff members here. So there's me, Richie, Jason, and Caitlin. So remember how I mentioned there's type inferencing? So Swift, whenever it sees this, it thinks that this type of this variable staff is an array of strings, right? Because I provide an array using these square brackets, and then the type inside, so the type of each element is a string. So the type of this is an array of string. Now to access a value inside of this element, you will need to provide it the position. So this is the first position, but everything in Swift, or the arrays in Swift, are 0 indexed, meaning that it starts with the number 0. So if I do staff at 0 and I run that, it should give me, I don't know if I can drag this out, but it should print out, or it should execute Vin, because this is the first element, the 0th element inside of this array. You can also assign a value to this array. So if I do staff at 0 is equal to, I'm gonna like Antoinette, then I'm basically modifying this array. So in other words, this array is mutable. However, if I were to change this to a value that is not of type string, let's say I do 3, then Swift will give me an error. Remember, everything in Swift is statically typed. So this is an array of strings. I can't give it an array, I can't give it a value that is not a string. But what you can do is give it an explicit type called any. So remember, I use a colon followed by a space, and then I give it the type of an array of any. So now Swift will allow me to change this value to an int. Does that make sense? Okay, there's also one more thing that y'all need to keep in mind whenever using arrays. So let's say I create a variable called, I'll call it staff again, and then I give it a type of an array of string, and then I can do staff.append. So there's also this method called append that allows you to add an element to the end of the list. So let's say I put Vin, I append Vin to this array staff. Now it's basically saying that staff was not initialized. So in order to add elements to this list, it needs to be initialized with an initial value. So you can do that by setting equal to an empty array, or you can do equals to an array of string, and then use open and close parentheses. All right, so make sure you initialize your arrays before adding elements to it. So that's arrays. There's also another common data type that y'all might use called a dictionary. So it's basically the same thing as an array, but instead of using numbers or integers as the keys, we can use whatever data type we want. So let me create a variable called staff age, which will be a dictionary where the keys are of type string and the values are of type int. So this is going to be a key value pair where the keys are the name of the staff and the values are the age. So I'm going to say Vin is, I think I'm 20 years old. Sorry, I forgot the equals. Yeah, so I create a dictionary. The value is of type int, and then the keys are of type string. So now if I want to access this value, then instead of doing 0, you have to put in the value of the key. So if I put in Vin here, this will give me 20. There you go. All right, so now just to kind of recap, an array is used to store a collection of data. And remember, type inferencing still works, so you can initialize it to whatever type you want without providing an explicit type. And then it can also hold any type if you would prefer, but normally we don't really use that. Dictionaries are basically the same exact thing as an array, but instead of using integers as the index, we use a key, which can be of any type you want. And then we use colon to separate it. Are there any questions? All right, so we're going to move on into conditionals.
Okay, so in terms of conditionals, let's say you want to take only you only want to execute code under a certain condition. So where you have, you want certain control over your code and you want branching options. So that's where sort of conditionals come in. So that's conditional statements. There's if, if, and else. So it's very similar to sort of the Python notation as well. So let's first set a variable a. Get rid of this. Let's set a variable a and let that be 0. So conditional would be if, let's say a is equal to 0, else print world. So here's an example of a conditional statement where the top of the code executes if a is equal to 0. So you provide the if statement with a conditional statement. So any of the ones mentioned before with equals equals, less than or equal to, anything that sort of evaluates to a Boolean can be inputted into that sort of space in the conditional statement. So if we were to run this, I believe it would, if this does work, it would print hello since a is equal to 0, and otherwise, if a was any other value, it would print world. So I don't think that printing is working, but okay. So if you see the terminal here, it actually prints hello here. So since a is equal to 0, it prints hello. If we change the value of a to something else, and where it's not equal to 0, it'll actually print the else statement. So we have world at the bottom now. So since it's not equal to 0 anymore, it will take the else statement. Let's say you actually wanted to add more sort of conditional statements rather than just if it's equal to a. Let's say you wanted to test if it is equals to another value. So that's the case where you would use an else if statement. And then let's say if it's equal to 1, print, let's say, and then you can add an else as well. So in this case, you have sort of two conditions that you check for first before you check the else statement. So if it's equal to 0, it'll print hello. And if it's equal to 1, it'll print Richie. So if we sort of run that now, if it's equal to 1, it won't actually go with the else anymore. It'll actually print the middle statement since we're checking for that second condition right there. And if it's any other value besides 0 or 1, it'll sort of return that else statement. So else is sort of the fallback for anything that's not covered in the previous condition. So as you can see, it says world there. Besides the base if and else statements, we also have something called a guard statement. So it works in a similar way, but instead of using an if or an else, we use a guard. So if we insert any sort of condition here. So the weird thing with this is actually this only executes if this is false, and it must not fall through, meaning that it cannot continue with the rest of the code if this statement is false. So rather than testing if a is equal to 6 and executing the code within the block, if a is not equal to 6, it'll actually execute whatever is here. So let's say error or something like that. And then usually you would have to not allow the code to fall through, either that be returning something or throwing an error. So in this case, we're just throwing NS error. I actually won't run this code because I believe if you just throw NS error in the workspace, it'll just crash Xcode. So I won't do that. But for example, let's say we had, let's set a is equal to 5. So in this case, this condition will not be met. So it would actually enter the guard statement. Because a is not equal to 6, it would go within this contained block of code right here. And then it'll print error and it'll throw the exception. Whereas if it is equal to 6, it'll allow the code to continue and then execute any code that follows. So that's the difference between the guard statement. It's sort of flipped in that it only executes the contained block if the condition is not met. Okay.
I guess a quick way to kind of like understand what a guard is. I know it's a little bit confusing because it's like the opposite of an if, but like how I like to think about it is basically think of this as like some kind of wall, right? So you're protecting this wall. You can't allow anything to go over unless this condition is met. So if a equals to 6, then you can go through. Otherwise, you filter out everything and put it inside of here. Does that kind of make sense?
I guess to recap, so we have conditionals. So in the sort of block of the conditional in the header, if in the if statement, you can have any sort of Boolean operation that returns a Boolean. So you can have and, or any sort of the comparison operators, or any function that returns a Boolean. And then you could chain those conditions with else if and else statements. And you can add in each condition. You don't just have to have one else if, you can have multiple else ifs. But you can only have one else statement. So you can chain an if statement with multiple else if statements and followed by an else statement. And as been mentioned before, there's also sort of the guard statement that acts as sort of the blocker. If that condition is not met, it'll execute that isolated block of code that you define. So if that condition is not met, then we'll actually execute the code that you define within the block of the guard statement. Okay, we'll move on to loops.
Yeah, so I'm going to quickly go over loops. It's basically a way for you to execute a code a specific number of times or even an infinite number of times. And so to create a for loop, which is basically if you want to loop over a fixed number of times, then you can do for, and then right after for, you provide this thing called a loop variable, which will live inside of this for loop. So normally we use I, but you can call it whatever you want. So now I'm going to try to print the numbers 1 through 10. So I can do for I in, and then to do 1 through 10, in Python, you remember how you can use like a range operator? You can kind of do the same thing in Swift. You can do 1 ... 10. And so now inside of here, I can do print I. Now if I execute this code, the console should print I 10 times from 1 through 10. Now, there's this thing called, though this is called a closed range operator, I can also use this thing called an open range operator, which instead of the last dot, you can use a less than, which is up to but not including the last one. So if I print this out again, it will be from 1 through 9. Now say I don't want to use this loop variable. Let's say I just want to print out like hello, in this case 9 times. Then you know how you can notice how Swift basically says you never use I. So what you want to do is just replace this with an underscore. You don't really have to do that. It just makes your code more clean and prevents you from having these yellow warnings. Now, in addition to looping over some range, you can also loop over arrays. So let's say I create a variable called ARR that has number 1, 2, 3. Go to 1, 2, 3. To loop over the array, I can do for, and then you provide in some loop variable, let's say I, in ARR. So now I will be the value of the array. So and now I can print I. Remember, I isn't the index, it is the elements. So if I print out I, it will print out 1, 2, and 3. All right, does that make sense? For the sake of time, I won't go over while loops because normally you probably shouldn't be using a while loop. But then again, a while loop does exist. So just to recap, if you want to loop over a fixed number of times, you want to use a for loop. So the closed range operator is inclusive, whereas the open range operator is exclusive. So it doesn't exclude, or it excludes the last number. And then you want to loop over an array, then you want to use a for loop. An unknown number of times you want to use a while loop, but that rarely happens. All right.
Okay, so we're going to go into defining functions. So usually when you're creating a program, you won't really just be typing out sort of code like this. When you're scaling to larger applications, when you're defining an app and everything like that, you'll sort of contain your code within functions so you can reuse that code. So you don't have to, so you can save code and reuse it if you need to. So the way you do that is you use the keyword func. and you define sort of what you want your function to be with keeping in mind that we do use camel case. So let's define a function called myName, and then we have no parameters. So that's how you specify it. Using the keyword func, you define a function called myName, and then we can make it print out myName. So myName. So if you run that, if you call that function using the same way here, you can call it, and Swift will often autocomplete for you. You can call the function, and it'll print out whatever you define within that block of code. So everything that you sort of define in that block of code will be called and executed every time you call the function. So using that func keyword, you can sort of reuse code without having to repeat anything, and it's much more scalable than typing everything out into the actual file. So let's say we actually wanted to add a parameter or user input. So we can include a parameter called name, and then you also have to specify the type. So we want it to be a string. And in this case, rather than just printing whatever a name is, and then we'll just actually use string interpolation to insert whatever parameter there is. And you'll see that now we have an issue that there's no more, there's missing a parameter for the name in the call. So we can actually just click fix to fix that, and you can see that we're adding that parameter name, and it's expecting a string. So if I sort of type vin in this case, we can run myName, and then we're calling on a vin. In this case, it'll call it on whatever you specify the parameter to. So you can call this multiple times, like that, and each time it'll just plug in whatever you plug in into the parameter itself. So there's actually multiple ways you can create shortcuts or rename these parameters. So let's say we wanted to sort of do something like that. It'll keep that sort of same. You'll use the parameter differently within the code, but when you actually call the function, it'll use the actual outside name. So that's something you can do as well. And another thing you can do is just skip that step entirely and use an underscore. In that case, you don't need to have to specify the beginning parameter name. In the case that you have one parameter, you can sort of just tell it to use whatever you input into the parentheses, and that works the same way, where you can run that and it'll print the same thing, except in this case, you don't have to have too much of the name stuff before, so you don't have to specify the parameter name in the function call. So there's also a return value that we can have for functions. So right now, I'm just printing something in the console. I'm not actually valuing any expressions or performing any operations. So let's say we wanted to actually return a value. This is how you would sort of specify the return type. So unlike some of the languages you may be familiar with, you have to specify your return type if you want your function to return something. So in this case, it's telling me that, oh, we're not returning anything, so we need to make sure that there is a return statement, and we can just straight up return the string. So in this case, when we call these functions again, rather than printing something in the console, they'll actually evaluate to a value here, which we'll see on the right. So yeah, if you want the function to return something rather than print something to the console, you have to specify the return type right here. So if you want to return a string, you would specify string. Let's say you want to return an integer. You would have to change return type to an integer, and you would just return the int. And in this case, it'll have an error here, but you can return the integer instead. So if you call that now, your return type is now an integer, so whatever you evaluate in the function must evaluate to an integer, and you return that as the value of the function when it is called. Yeah, that should be about it for functions. I guess for a recap. So we define a function using the func keyword, and if you want that function to return anything, you need to use that arrow symbol. It's just a dash with the greater than symbol. And then you need to specify what type you want to return. If you don't want to return anything and you just want it to print something or perform an action without returning a value, you don't need to specify the arrow. And you can also pass in arguments through parameters in the function call, and you can sort of manipulate how you want the parameters to behave with the methods I showed before. So okay, let's move on to, question?
How do you delineate different parameters? Like what if you have multiple parameters?
Oh, okay. So I can cover that real quick. So if you had like multiple parameters, you couldn't really do the sort of thing with the underscore. So if you had like addition, you would just use a comma to sort of separate the two parameters, and you would also need to specify the value of the second one. So let's call this add. So if we wanted to return the addition, it's just plus number 2. And we can do, right, so that's the example you would have if you have sort of 2 parameters. So you would separate them with a comma, but you would still perform the same thing with the parameter name and the value of the, or the type of the parameter. So in this case, if we run that, it would just return 4. Yeah. Did that answer your question? Okay, perfect. Okay.
All right, so we're gonna have to go a bit over time because optionals is like one of the most important things you will learn. So we're gonna spend a little bit more time on this. So essentially what optionals are just basically, it's a type that can hold this value called, or not even a value, it can hold this thing called nil, which basically means no value. And so to demonstrate an optional, I'm going to create some kind of function called, I guess, get favorite sports. It's going to take in some kind of sport, which is a string, for example. And then it's going to, or I'll put in a name, right? And then it's going to return in this thing called a string optional. So you can denote an optional by providing a question mark. So now what this function is going to do is I'm going to pass in a name of a person, and it'll return this person's favorite sports. If that person is not there, then it's going to return nil. So to do that, I could say if name is, let's say Vin, then I'm going to return, I'm going to do it in one line just to keep things, I guess, nice and neat. If name is Vin, then I return tennis. So tennis is my favorite sport. Return tennis. So if my name is Vin, then I return tennis. Now, otherwise, let's say anyone else, I'm going to return this thing called nil. Okay? So I'm going to call this function and then pass in myself. So I'm going to pass in Vin. And let's say I'm going to save it to some variable called A. So variable A is equal to get favorite sports, and then I'm passing name to it. So if I run this code, then the value that this function returns is tennis because I passed in Vin and it went through this if statement and then it executed this code. Now what happens if I were to pass in something that's not Vin? So let's say I put in Richie. Okay. If I run that, now it says that the value that I returned is nil. So the purpose of having this, I guess, optional is because sometimes you want to be able to represent data that is not there. So if you use a string, you can use an empty string to show that something's not there. But sometimes that's not like that's not good practice. So in Swift, we use this thing called an optional. So now let's say I declared this variable A with a type called string. So I'm going to remove this. So now A has to hold a type string. So let me assign A to be equal to the return value of this function. And I put in Vin. So now Xcode gives me this error saying that this value must be unwrapped. So what's happening here is that this function returns a string optional. However, this variable A must take in a string. So those two are completely different types. But in order to access the non-nil value of this optional, I need to do this thing called unwrapping, optional unwrapping. So to unwrap, you can use this thing called an if let statement. So I can say if let, I guess, Vin's favorite is equal to get favorite sports. I'm just going to copy and paste this. So now what's happening here is that I'm basically letting this variable or this constant called Vin favorite be equal to the non-nil value of this function. So if I were to assign A to this variable, you can notice how whenever I like hover over it, it basically tells you that the type of Vin favorite is now a string instead of a string optional. So in other words, I unwrapped this optional by using an if let statement. But if I were to, use Vin favorite in here, or it's not defined, but if I were to, I guess, if I create a variable called, or if I assign a equal to Vin fav in here, it's not going to work because this variable only lives within the scope of this if statement. Now, you can also use a guardlet, which basically kind of inverts this, meaning that you can use Vin favorite outside of that function, or outside of this block of code. Now, there's also another way to unwrap this optional. I can use this thing called force unwrapping. So now, let me say a will be equal to get favorite sport Vin. To force unwrap, you can use an exclamation point. So it basically unwraps the non-nil value of this function. So if I run this, then the value of a will now be equal to tennis. But there's a problem with this. What force unwrapping does is that it forces it grabs the value of this optional. But what if that optional does not have a value? What if it's holding nil? So let me try passing in, I guess, Richie. So if I were to pass in Richie, then this function would return nil. And so now I'm force unwrapping it and assigning it to the value a. So now if I run this, now you can see that I get a fatal error. Now when you're creating your iOS applications, if you were to force unwrap an optional, if that optional were to hold nil, your entire application would crash. So whenever you're creating your apps, if you click on a button or something and your app crashes, that's most likely because you are force unwrapping an optional that's holding nil. In other words, you should rarely be using force unwrapping. So just to quickly recap again, optionals are a data type in which it can hold the value nil, which basically means no value. And we want to use an optional instead of using an empty string or using 0 for an int because it makes your code a lot more robust. And you can indicate an optional by appending a question mark to the data type. So a string optional will be a string question mark. And now to unwrap the value, the two ways of safely unwrapping it, the two common ways, will be using an iflet or a guardlet. And then again, you can also force unwrap, but you should not be using this in the course unless you know for certain that that optional would not hold nil. For the sake of time, I won't go over optional chaining or nil coalescing, but you can also read that in the textbook. Actually, I'll quickly go over it. So basically, I can use a double question mark. This is called nil coalescing. It basically provides a default value for this variable in case that this thing returns nil. So I can just say his favorite sport is like soccer, for example. So now if I were to run this code, it will now execute soccer because this thing returned nil, but I provide a default value of soccer. So this will be a very common way to kind of prevent the issue with force unwrapping. And there's also this thing called optional chaining, but the textbook goes a lot more in detail. Are there any questions? Okay. For the sake of time, we won't take attendance with Kahoots, but just some to-dos, some action items. We're going to release A1 tonight. It's going to be about Swift Basics, and it's due next Monday at 11:59 p.m. So after Monday's lecture. And then again, we will create the repositories for you, so don't worry about that at all. The assignment handout should have like all the information about how to clone and stuff. And then again, this is by yourself. You shouldn't have a partner for this assignment. I will release the mentorship and partner preference forms for the future assignments tonight, and it will be due Sunday, October 15th. And so basically what a mentorship is that one of the core staff will be your mentors. It's basically someone that you can like bug around. It doesn't have to be iOS related. You could just like bug them about whatever you want, to be honest. But it's just there to, for fun. Yeah. Are there any questions about course logistics or anything? All right. Y'all are free to leave. If y'all have any questions, just come up.